Hello and welcome to Inside Exercise. I'm Emeritus Professor Glenn McConell from Victoria University in Australia, and I'm also currently a Danish Diabetes and Endocrine Academy visiting professor at the University of Copenhagen in Denmark. The idea behind Inside Exercise is to bring to you the absolute who's who of exercise research. So exercise physiology, exercise metabolism, and exercise and health. And what I'm really wanting is for you to get your exercise information from the research experts rather than from influencers. And indeed, today I'm bringing to you Associate Professor Nisha Charkoudian from the US Army Research Institute of Environmental Medicine at Natick, Massachusetts, USA. She's an expert on the physiology of exercise in extreme environments. So we talked about that, but we also talked about the importance of considering sex as a biological variable. So we talked about some sex differences in responses to exercise, especially in the heat. For too long, studies have tended to focus on young, white males, and we talked about the need for more diversity, and in particular how ideally you would involve males and females in studies, but even if you don't have sufficient numbers or sufficient budget to actually have a full complement of males and females, Nisha made the point that you could always leave a subgroup in there for comparison. So you might have mainly females and a few males, or mainly males and a few females. And instead of doing what has tended to happen over the years where you say, oh, we're underpowered, we'll leave that out, she's saying you should leave that in for comparisons. So that was an interesting discussion that we had. And she has a recent viewpoint on that, which we discussed. We also talked about how research in this field tends to concentrate on young, healthy people, and there hasn't been enough research with older people as well. I found it really interesting. I think you will too. So stick around. Now, of course, I'd prefer you to watch the whole podcast to get the full context. But if you wanted to, you could look down in the notes and you'll see there's timestamps. So on YouTube, you'll look down there, you'll see in blue the time that we talked about different aspects. So you could skip around a little bit if you wanted to. On the other platforms, you can see the times, but you can't click on them. Also, if you could do me a favor and help get the word out about Inside Exercise, if you like, subscribe, leave a comment, etc., the algorithm will tend to respond to that by making it more likely when people search for a particular topic to suggest Inside Exercise. So that would be great. Okay, so enjoy the chat. Hi, Nisha. How are you? Welcome to Inside Exercise. Thanks for coming on.
Thank you so much, Glenn. Thank you for having me on your show. And I know I'm very honored to be included in this very excellent list of speakers that you've had to date.
Oh, no, you fit in very nicely. And I had a lot of, I know you're not on Twitter that much nowadays, but there's a lot of interest, a lot of questions and things. So I think you fit in very well. All right, so we're going to be talking about physiology of exercise in extreme environments and sex as a biological variable. How about we just sort of break that down a little bit, talk about what are we talking about with extreme environments, and then, sex as a biological variable.
Sure.
What do you think about that? Yeah.
Absolutely. So I just want to start out by saying that I'm not really talking today about my work with the military specifically, but I do work for the United States Army, and the views I'm expressing today are my own views. They do not represent the views of the U.S. Army or the Department of Defense. So with that out of the way, when we think about extreme environments, I think with climate change especially, it's been receiving a lot of increased attention in recent years, appropriately so. I think everyone's glad. Everyone in the scientific community is glad to see it's receiving increased attention. So it's a vague term. I would say that it's not specifically defined, but extreme environments in my mind is extreme heat, extreme cold, or high altitude. And a lot of times, as you know, Glenn, those environments come together. So often if you're at, for example, a high altitude environment in Alaska, you're also going to be experiencing extreme cold. So one of the main focuses of my work and my team's work over the past 10 years or so has been to try to identify what we can learn about the physiology and the pathophysiology of responses and adaptations to those extreme environments, and then try to understand how we can improve individuals' health or performance during those extreme environmental exposures.
Okay, so I guess we can all imagine like being frozen to death or up the top of Mount Everest or whatever. But is there some sort of cutoff there? And I guess the other thing I think about is if you're exercising in the heat, right, and it's really hot, whether it's extreme stress to the body will depend on how fast you are. So if you're running a marathon, you're really slow. Because this is something I remember when I was doing my PhD, people always thought that people got the hottest in a 10K race, for example, or the ones that didn't
Oh,
drink. And then it became apparent, no, it's the actual ones that are going the fastest because they're producing the most heat, that they tend to get the hottest. You know what I mean? So I guess, is there any sort of, I'm being a bit pedantic here, but I guess, do you have sort of a cutoff, like maybe we could talk about the wet bulb, dry bulb sort of thing for heat, or
well,
does
yes,
it
but
sort of
before we
depend?
absolutely. So before we do that, Glenn, I want to just slightly correct something you just said, or not correct, but just add
Fair
some
enough.
modifications to it. So because I think about this a lot, right? And so a lot of the work that we do has implications for athletes, for elite athletes, for not so elite athletes, for industrial workers around the world. One of the reasons that some of the first environmental physiology laboratories were stood up was because of mining operations. For example, in the 1960s in South Africa, there were mining operations, and one of the reasons they did the first sets of research studies, Cyril Wyndham was one of those authors in the 1960s, was because they were just trying to increase productivity in their mining operations. And so you can argue about the ethics of that, which is a separate issue. But so I think a few things that I wanted to mention when you talk about athletes and people competing in the heat is that it isn't necessarily true that the people who run the fastest marathon are at the highest risk. It is true that if you have if you're running at a faster pace, you will have higher metabolic rate, and therefore you will generate more heat. However, in some cases, running a longer marathon, so the people who are the slowest and maybe the least fit, may be at the greatest risk of heat illness because they have the most time for things to go wrong. So for body temperature to increase, maybe if they don't know about their hydration status, they're drinking too much, so they might be at risk for hyponatremia, which is a whole other issue. Right. And I think that the thing that I've been, when I speak with students or others recently, the thing that I've been trying to emphasize is there isn't, and this is where you can tell I'm kind of trying to stay away from absolute numbers, because there's so much inter-individual variability among humans that there isn't a like one set of environments, or we sometimes talk about wet bulb globe temperature. There really isn't one temperature that is dangerous for, I mean, at a given point, certainly there is, but and I guess part of the reason I'm saying that is there used to be this idea that there was a core temperature of 40 degrees that was critical. So if your core temperature reached that level, you were in danger of everything: heat stroke, collapse, organ damage, etc. But that isn't true, actually, because there's evidence in the literature now of people who run races and do reach core temperatures above 40 degrees and are fine, actually. They may be tired at the end of the race, but they do not have heat stroke or heat illness. So, so I think, I guess the important point I'm trying to emphasize is the inter-individual variability. Now, certainly the type of environment that you're exercising in matters. So if we're thinking about heat, everyone anecdotally has experienced that heat is less comfortable when it's humid and more comfortable when it's dry, to a point. Certainly very, very dry environments are also not comfortable. And the reason for that, as we know, is because sweating is one of the major ways that humans dissipate heat. The other major way is by a dilation of the skin circulation. So if the skin blood flow is carrying the heat, if we think of convective heat transfer from the core to the skin, or from the exercising muscles to the skin, if the skin blood flow is carrying heat more or less to the surface to be dissipated to the environment, it has to work with sweating to dissipate that heat to the environment. So the sweating is there but not evaporating. It's essentially not doing anything, and it's wasted water. And if anything, it's contributing to potentially increased dehydration, because that sweat is just dripping off the skin, and it's not really doing its job at all. So those are some considerations, whether you're in humid environments, whether you're in dry environments. Certainly hydration status has a big role in all of this, but it's not the only thing. So if we're thinking about extreme heat, I feel like we're focusing a little bit on extreme heat right now. So if we're thinking about extreme heat, I think there's a little bit of a misconception in some folks that I've interacted with, that if you remain hydrated, you're fine. Like, so if you're hydrated and you have enough access to water, you won't get heat stroke. That is incorrect. And it sounds obvious when I'm just saying it like that, but I think people sometimes get a little bit narrowly focused because there has been a lot of focus on hydration in the kind of sports medicine area over the past 10 or 20 years. So I definitely think, to be clear, I definitely think that, before some of my colleagues start calling me, I definitely think that hydration is really important. We must stay hydrated because dehydration does put you at risk for increased core temperatures or for heat illness or heat stroke. However, it is not the only risk factor for heat stroke. And I think that's where sometimes people get confused. So certainly you can be perfectly hydrated and then, still have excessive rises in core and skin temperature, still have shifts in cardiovascular function that are such that your cardiac output can't keep up with the requirements for blood flow to both, your working skeletal muscle and the skin for heat dissipation. So I often view heat illness and heat stroke to some extent as really a cardiovascular phenomenon, because it really has to do with, the person has to maintain these very high cardiac outputs, and at a given point it's just not possible, and that's when some of the collapse occurs. And I think that contributes to the altered mental status that occurs during heat stroke. It contributes to the blood flow changes, the GI blood flow and permeability changes, and then some of the organ damage that can occur with very serious heat stroke. So let me pause there and see, since I've been talking for a while, see what you have to say.
Yeah, okay, that's very interesting. So yeah, as you say, it's obviously complicated because it depends on how much energy. So if you're going really, really fast and it's short and you don't actually have time to dehydrate enough, then obviously it's the how much energy you're actually producing that's the most important thing. But then if you're going like really, really long and you're not hydrated enough, then that's going to be a problem. But also, I guess it depends if you're hydrated when you start as well. So there's all these,
it definitely
you
does.
know how they say you should drink until, do they still say that? Because when I used to be a serious runner, it was like, drink until your urine is clear before you start. Is that still the sort of thing people talk about?
So
without going
hyponatremia,
hyponatremic before it. Yeah.
Right. So I think in answer to your question, it is important to make sure that you're hydrated before you start any athletic event or endeavor. I would not say that you necessarily need to continue drinking until you see completely clear urine. I think some people have interpreted that in an extreme way, so that sometimes you'll see athletes walking around with like giant gallons of water, that they're just drinking water all day long. I think that's kind of overdoing it, right? And I think that kind of mentality is a thing that can lead to over drinking and hyponatremia if we're not careful. Now, hyponatremia, as you know, Glenn, doesn't happen often. Luckily, it's rare, but it is life-threatening when it happens. So we just have to be careful to say, okay, let's make sure that we're drinking enough water so that we feel hydrated. Certainly this idea that there was an old idea that if you're dehydrated, then you're lighter, like your body weight's lighter, so therefore you can kind of run better or faster. I definitely do not subscribe to that. That's, I would say, a very old idea. But so we don't want to do that, but we also don't want to have our athletes or just regular recreational, exercisers thinking that they need to drink all day long, drink water all day long in order to be appropriately hydrated. That's incorrect. So
I should have clarified. So when I said I was a distance runner or whatever, I was talking about before a race. So, I wouldn't be like always wanting my urine to be clear. No way.
Right.
Just normal. And then the day before a race or something, you just sort of drink, and it's like, you try and, make sure you're pretty well hydrated, because a lot of people are chronically dehydrated. Is that fair to say? Except the ones that are carrying gallons of water.
I think that's less true than what was previously thought. I think so. For example, things like urine color and urine specific gravity, which is something else that we do in the lab, are the best indicators, but only first thing in the morning. So it's only if it's your first morning void. So I don't. So definitely, if you had some very dark urine color, I would say go ahead and drink some more water, but I wouldn't say that if you had kind of a normal first morning void, you had to go and like chug a bunch of water before an athletic event. You should have some, but again, I think this focus on having completely clear urine is maybe a little bit overstated.
That's interesting, and I know as well because the races would always be in the morning, and we'd all get nervous and be lining up for the toilet. So it's probably like, maybe I shouldn't have drunk so much.
Right, exactly. So then you run into that problem, right? Because then you have,
exactly.
So I think it's like it's just like anything else, like a balance. In the athletic community, of course, I think people tend to, try to do these extreme things. Like I must have, my pre-workout supplement, or I must have this, I must have that.
And all these
anyway.
electrolytes. I wonder what you think about, okay, I'll get to that in a minute. So all this talk about electrolytes, all these ads for electrolytes and all these people taking electrolytes. But I'll ask you about that in a minute. I was just thinking earlier when you were talking about when it's humid, you're not evaporating, so it's just dripping off. The classic thing, the Australian Open every year, it's often very hot. And they'll be like, oh, this guy, so Pat Rafter, who used to be whatever, he sweats like crazy, because it's dripping off him. And it's like, no, because it was humid yesterday, and it's like, oh, he's not dripping, he's not sweating as much today, he's cruising today. No, it's not, you know what I mean? So people don't, I'm sure you know.
Exactly.
What I mean. People don't necessarily think about that. If it's humid, it's hard to evaporate because the air's already got a lot of water vapor. So it's hard to, to evaporate that. And when it's dry, it's easy to evaporate it. Okay, now I'd like to ask you, and we will get into I want to talk about the sex as a biological variable, but just while I think about it, and you mentioned electrolytes, what do you think about it? To me, it seems like everything's gone sort of crazy, to be honest. The world's gone crazy. Everyone wants these protein shakes and electrolyte this, and it's like, just train, just eat food and train hard. What do you think about there's all this stuff about everyone's worried about electrolytes? Because I remember a classic, was it Susan Barr? I did my master's at Ball State years and years and years ago. She did a study, like 6 hours walking on a treadmill, and whether they drank or not, or whether they had electrolyte drinks or not, the sodium was almost the same in the blood.
It didn't matter, right?
Adding this little bit of salt and whatever doesn't make much difference to this huge amount of sodium in your body. So do you have any thoughts on any of that?
I definitely do. In fact, I'm very concerned about the industry around what's called oral rehydration solutions. So the solutions, the things like that have higher concentrations of electrolytes compared to like Gatorade and all that is fine, in my opinion, and in the opinion of a lot of people who have done work in this area. And I can point you to some literature if you want, but you do not, as long as you have access to regular food and you're eating normally over the course of a few days, and you're drinking normally, you do not need any electrolyte supplementation at all. You're perfectly fine just drinking water. And if you want Gatorade some people find it more palatable, so therefore they're more likely to drink it more. Some of these other there's a category of substance called oral rehydration solution, or ORS. It was actually developed by the World Health Organization for treatment of diarrheal illnesses in children in hospital settings. That's what it's for. But for some reason, some of these companies have been trying to market their product as preventing heat stroke. And actually, it's extremely frustrating to me and several of my colleagues that they try to do this because A, it doesn't prevent heat stroke. B, it's expensive and you don't need it. So this whole idea that you're going to do better or feel better or prevent illness if you have these very high electrolyte solutions, which are medical products, is absolutely incorrect. It's scientifically incorrect.
Because if anything, your sodium levels go up during exercise. Yeah, depending on if you drink a lot.
And as you know, Glenn, sodium and osmolality are extremely tightly regulated. It's very difficult. It would be hard to get your sodium down if you actually tried. That's why hyponatremia is rare, which we're lucky that it's rare because it is life-threatening. But it would be very difficult to change your sodium levels. So definitely, if you're feeling tired on a race, especially a shorter race, it's not because your sodium's low. It's not because you need some high electrolyte solution.
And then they take your magnesium because they're worried about cramps. And, just keep it simple, people. Just get out there. And,
just eat food. Eat healthy food, eat vegetables, eat a balanced diet. Don't go to these extremes. Everyone wants to do these extreme things, and it's really not necessary and sometimes dangerous.
And obviously, you mentioned Gatorade. We're not saying don't have a carbohydrate drink if you're doing an exercise where your glucose is going to drop and you're going to get glycogen depleted and whatever. We're just talking about the electrolytes, right? Just to clarify.
And don't avoid them either, but I'm just saying you don't need these really expensive, super high electrolyte things. Any of I'm just using Gatorade as an example. I'm not promoting Gatorade. Any Powerade, any of those drinks are fine. If you want that kind of carbohydrate electrolyte supplementation, great. If you like it, maybe it'll just make you stay hydrated more easily. Maybe it'll replace some carbs for you if you're in a longer event. But just don't feel like you need to go overboard and spend your life savings on something that really isn't necessary.
It's funny. I won't say the company, but I had funding from a carbohydrate drink company years and years ago, and I did the study, and then I wrote this sort of story for the local my local university newsletter, and said you don't really need carbohydrate drink. You might need carbohydrate drinks, but not if you go to the gym just for an hour or whatever. You don't have to worry. Your glucose isn't going to drop. But if you want it, just make it up, just sugar and water. And if you want to add a bit of salt, just stick it in there. So then I got like all these phone calls, like, we just gave you all this money. And I said, I didn't say I was going to tell people to drink it every 2 minutes. Anyway, okay.
Right. Exactly. So we're on the same page, Glenn.
Right. All right. So why don't we think about, and I know we can bring in lots of things, but why don't we just think about the sex as a biological variable? Do you want to just explain what you're thinking there?
Yes, absolutely. So let's see. There's a few different ways of thinking about this, but I'll kind of explain how I think about it. One that everybody knows, and I definitely don't need to tell you, is that a lot of the work in thermoregulation and all of physiology and biomedical science has been historically done primarily in young white males. Mm-hmm. So what has happened in numerous examples, not just in thermal physiology, but what has happened in a lot of areas of biomedical science, is that that data from young white males has been extrapolated to other groups, including women, including other ethnic or racial groups, inappropriately. And in some medical scenarios, which is not my expertise, those medications haven't worked correctly, or there's been serious issues like that. So what, in my estimation, appropriately over the past 10 years or so, probably too late, but people have been saying, let's just pay more attention to making sure that we're including women in all studies, so that we're not taking studies that were done in men and trying to extrapolate those results to women. Now, there's a few areas to that if you think about it. One is that there's a couple different ways of thinking about that. One is, are there sex differences in some variable? So for example, an example that I speak about a lot is you'll hear there's older historical data about sex differences in thermoregulation. Women don't thermoregulate as well. Women sweat less. You hear things like this sometimes, right? Mm-hmm. Well, because of that, this is where I get a little irritated. Because of those kinds of data, or because of those kinds of statements that were not based on actual data, there were rules against women participating in endurance events. So up until 1972, I live in Boston. Up until 1972, women were not allowed to participate in the Boston Marathon. You may have seen some of those pictures. There was a picture from the Boston Globe from 1968 of a woman who got forcefully removed, or tried to get forcefully removed from the marathon, because she had signed up under her initial. And then when they found out she was a woman, they were trying to take her out of the marathon. It was terrible. I mean, 1968, that's not that long ago.
Wouldn't shouldn't perspire, they were saying, or something.
So if you look at the
ridiculous. Mm-hmm.
Exactly. So if you look at the literature, you see these statements that are based on kind of anecdotal, unsubstantiated reports of women, quote unquote, sweating less. So if you look at kind of the more recent literature, if you think of like from the 1990s to today, where people have started to look at more controlled for fitness level, controlled for activity level, you'll see that there are not huge differences between men and women in thermoregulation. There are some differences. So for example, at the very highest levels of exercise and heat humidity, so if you look at the highest levels of heat strain, there's something called E required, the requirement for evaporative heat loss. So how much do you need to evaporate of sweat in order to maintain a kind of a steady state body temperature? At the highest level of that E required, there is a slightly different, slightly lower maximal sweat rate in women. That is true. But there's other sex differences that, in my opinion, kind of offset that. So that, for example, women are better able to adapt to, like during heat acclimation. There's limited data. We're actually working on a study in my team right now where we're trying to look at some of the sex differences in heat acclimation. But there's evidence that men and women adapt differently. So women's sweating response adapts more quickly, whereas men, the heart rate response adapts more quickly, just for an example. But so I would say that overall, the literature shows that there are some differences in very specific points of thermoregulation, but those things do not affect the risk of heat illness. So we can't go around saying that women are somehow more fragile, which drives me crazy. And therefore, we need to not allow, and that doesn't happen anymore. Women are allowed to participate in endurance sports, but I think that bias is a little bit, you'll hear it every now and then still out there, right? And so, so I think it's really important that we just emphasize, and our team just published a paper this year, I think earlier this year, it came out in American Journal of Physiology, that where we actually looked at epidemiological risk of heat stroke in 4,500 young, healthy men and women, and showed that the risk was, in fact, not different between men and women for a variety of activities, including long marches in the heat and things like that.
Okay, well, it's a bit of a tricky one. I was just thinking, because in a way it could backfire in a way if we found that everything was the same, which isn't, because I'm actually amazed how often things are different. But you're saying, in terms of heat, etc., it seems like things are pretty similar. But it could almost backfire in a way if people would say, well, if there's no difference between men and women, you might as well just study men. When in theory you could say, well, there's no difference between men and women, you might as well just study women. But that's not the way people tend to think, is it?
Exactly. So that's, I was kind of, thank you for bringing that up, and I was gonna get to that. So first of all, saying that women are not more fragile than men, or less heat tolerant than men or something, is not the same as saying women are the same as men. Those are not the same statements. So so I think we always need to, we don't have time to go into it today, but there are specific differences, and I think that's an area of work that myself and my team are trying to clarify a little bit more. So there are areas that we still need to understand in terms of reproductive hormone influences. Some of my first publications had to do with reproductive hormone influences on control of the skin circulation during whole body heating. And there are specific influences that have to do with how both endogenous or exogenous, meaning like oral contraceptives, estradiol and progesterone, affect the skin circulation, as an example, in terms of thermoregulatory responses. So it's I agree with you. I have heard the idea that, oh, well, if you just show there's no differences, then you could just go back to studying, white men. Well, no, that's not true. And I think so that kind of brings me to my second point, if it's okay, regarding this area, which is that we have to include women in our research studies, period. So I've talked to people very recently, like in the last 6 months, who have said they're not including women because they're concerned that they don't have the funds. So either, I hear a few different things. One, they don't have the funds to double their sample size to study sex differences, or two, they don't have the resources to control for menstrual cycle and measure hormone levels and those types of things. So I think it's fine. So my answer to that is, first of all, don't worry about it. Just do your best. Secondly, I think it's great if you want to study sex differences, but including sex as a biological variable, just like every other biological variable, does not mean you power your studies to have statistical power to study sex differences. It's not the same thing. So, and similarly, I would be delighted if everybody, including me, had the resources to control for menstrual cycle all the time. But if you're studying 500 women in a field study, you're not going to be able to, or at least no one I know is going to be able to, right? So,
that's interesting. Can we just clarify that?
Sure, of course.
Yeah, I guess so. Those arguments are the age-old arguments, and as you say, it's often valid, right? You don't have enough money, but then you could go, well, all right, so we've only got enough money to do one sex, then you could say female, right? But people don't tend to think like that. But it does get complicated because, as you alluded to, the menstrual cycle. So then you've got to try and get everyone the same. And then should you do follicular? Should you do? And it becomes difficult. Yes.
No, that's what I'm saying. It shouldn't be difficult. I'm saying it should not be difficult. I'm saying
no. What I mean is, if you've only got that amount of money, if you've only got amount of money to,
but that's right. But that's what I'm saying, Glenn.
Mm-hmm.
If you only have the amount of, like, okay, let's think of a specific example. I'm really glad you're bringing this up because I think it's really important. Let's say that you have a
tricky one for me. I have to say, as a male, so I've had, thankfully you're the third. So I'll just point out to people, I've had Kirsty Elliott Sale on. We've talked about some of these issues. I've had Abby Smith Ryan on talking about these issues, so I feel about. But I am like a white male, you know, and I'm also
yes,
like
I noticed.
age that I'm the problem sort of thing. So apologies if I do say things wrong here and there. But what I think was really good when I had Abby Smith Ryan on is I realized that I'm probably doing the thing as well. I'm mansplaining or something, cutting you off. So sorry about that.
No, it's fine. You're doing great.
I kind of went from thinking, oh, you're just doing studies because you want to look at sex differences, and hadn't really thought properly about the fact that obviously often you're interested in only the woman. It doesn't have to be, you know, obviously if it's a menstrual cycle, then everyone goes, oh, okay, well, you can't look at men with that because that has to be woman, right? But just the thing is, it's always been like you look at men and you see what you get, and then, okay, I wonder if it's the same in women, right? But rather than just saying, let's see what happens in women per se, without even thinking about the men, that was a bit of a thing for me that sort of the penny dropped.
I'd like to add to that. Certainly, you can just study women. I mean, if you're studying the menstrual cycle, you just study women. If you're studying prostate cancer, you just study men. I mean, it's just that's one thing for sure. I think what I'd like to add to that is I don't really ever want to see groups that are just men or just women if it has to do with a general question that's being asked about human physiology generally. So I guess one way that I think about it is we don't want like white men or white women or any group to be the default human for anybody. We want to have our groups as integrated as possible. And I think that's a new way of thinking about things for people who have historically, including me, by the way, who have historically felt like, let's start with the young, healthy male as like the baseline. Well, why? Why is a young white male the baseline? It's not a default human. There's tons of humans out there that are different, right? So why not just include, let's say we have a budget that we can study 15 people in an exercise test, let's just say. Why not just start with whoever we can get, as many women, as many men as we can get? So if we end up with equal numbers of men and women, fine. If you have 2 women and 13 men, then you're not powered to study sex differences, but at least you've included some women. I think I'm really glad we're talking about this, Glenn, because I think this is a big misconception that is out there, that if you're going to include women, you always have to study sex differences, or you always have to control for a menstrual cycle. That's not the case. I would much rather see people include women and not control for menstrual cycle rather than not include women. Does that make sense?
Ooh, but sometimes the reviewers give you because that was the thing I was thinking, and that's what the thing you touched on earlier, that so you might have 10 men and 2 women. You're saying, I just feel like the reviewers would say, hang on a minute, just leave those, because that's not adding anything. You know what I mean? So
let me put it this way. I sit on the editorial board for the AJP Heart and Circulation. And I was up until recently, an associate editor. I'm now a consulting editor for that journal. We just published, and you can see it came out the past couple months, a position stand for that journal, which says that which says more or less what I'm saying right now, and we need to include men and women in all research studies. So that does not mean that you can.
You don't have to be powered for both.
You don't have to be powered to. I would for example, if you just have to be specific about what your research question is. So if you present 8 men and 2 women and you say you're studying sex differences, then I'm going to say no. But if you present 8 men and 2 women and you say I'm studying exercise responses to 2 hours of walking in the heat in all these people, here's the data, then I would say, okay, great, that's fine. And if reviewers have an issue with that and they say that you should just leave out the women, I would have a big issue with those reviewers.
Okay, well, this is really interesting. It kind of makes sense. It's sort of the way I was kind of beaten out of me. But what it used to be was you'd say, okay, let's get a bunch of people, and you might have, like you said, 10 men, 5 women, 5 men, 10 women. And you'd say, well, but then it would be, if you thought there wouldn't be any difference, then people would say, okay, you could combine them. So just say you looked at the effect on heart rate or sweat rates or whatever, and they didn't see any difference, then you'd combine them. But you're not saying that necessarily. You're saying you would have the 10 men and 5 women. What are you saying? You're not saying you say there's no difference and combine them. No.
Right. So I think, so again, Glenn, I just want to emphasize, like, I'm so glad we're having this conversation. It wasn't necessarily what I thought.
I feel like I'm screwing it up, so I'm glad you're not.
No, not at all. Not at all.
Okay,
These are conversations that are really important. And it's kind of one of my, in fact, I'm going to tell the editor, Mary Lindsay, I'm going to tell the editor of AJP Heart to listen to this because I am trying to.
I'm glad, 'cause I feel like I'm totally screwing it up.
Not at all. You're not.
So
But I think these are. This is why we're doing this, and this is why the journal, had this this special editorial. So I guess the thing that I just want to come back to is to say, I think there's been this kind of historical tendency to say you start with a group and then you add women or you add something else after you start with the men or something like that. And I just think that's not the right way to think about it anymore. It's like, it's kind when I say sex is a biological variable, I mean, it's a variable. It doesn't mean you're always studying its influence, but it's a variable, just like blood pressure or hair color or anything. So you certainly wouldn't like separate out and start with all, women with black hair or something. Like you wouldn't do that. And then see if there's a statistical difference with women with blonde hair. You wouldn't. So like, it's the same thing with biological sex, is to say, let's just include a group. Now, definitely, I know where you're heading with that. So you could say, well, what if there was a huge difference, right? So let's say there was a huge difference between men and women, and you only had 3 women, so you didn't have the statistical power to detect it, right?
Yeah.
I see where that argument is. I'm not ignoring it, but I guess what I would say, and what I think the journal, I can't exactly speak for the journal, but what I think a lot of the journals, not just the APS journals, but many journals today would say is like, well, then you've identified something that's important to follow up on. So if you like, let's say you just did, your 10 men, and then you didn't include any women because you had 3 women, but they were really different. Like their blood pressure was much lower or something like that. Like, let's say you had a situation like that. Well, then still include them.
Okay.
And present the data as a group, and then say, here's
research.
Exactly. So here's a anecdotal observation that we had that is maybe important, and we need to do some follow-up work on it, because definitely that's where some of those important findings start from. And if we just exclude the women in the first place, or exclude the men for that matter, I mean, let's say you study 15 women and the men would have had a different response.
I'm actually remembering some studies where we purposely, we were just recruiting either, and it just turned out that we had, like eight men and 1 woman, one female, and it's like, crap, and we ended up leaving her out because we just thought it's going to be a mess.
No kidding.
Yeah, one study. But you're saying even back then, that was 20 years ago. That was the 1999 paper. You're saying back then you would just include that
yes,
that one.
And I did actually.
So stats, or what would you?
No, just mix them all together, and then certainly if there's outliers, so
respond differently, it messes it up.
So Glenn, let's just say you had a group of, never mind sex, let's just say you had a group of men, and you had an outlier. You had a group of 10 men, 1 guy had a completely different response from everyone else. Then you could determine statistically if that person was an outlier and remove them from the analysis. Same with if you had 3 women and 1 was an outlier, or 2 were an outlier. Outliers, so I think it's something that has to be thought about very carefully. And I guess all I'm saying is, let's think carefully about how we do it, rather than just saying, well, it's easier just exclude the women or exclude whoever's in the minority or whatever, something like that. Like it's just not okay anymore to do that kind of thing.
All right. Well, that's I guess I'm obviously haven't caught up on that. Okay. So now that we're having this chat, and we've, and I've been confused and whatever else, is there other stuff you want to get out? Like that you wrote in that editorial or whatever, that we should, so what are some other things that you wanted to make sure people are clear on?
So first of all, it was a huge group of authors, not just me at all. I'm in the middle somewhere of this giant group of authors, led by Mary Lindsay as a senior author, and Charlotte Usselman from Canada was the first author on that. So I guess the idea is, and part of our goal as a group, again, at the risk of speaking for a huge group of people who I admire quite a bit, is just to say, hey, let's do our best to include women in studies, period. If we can do better than that, meaning like if we can control for menstrual cycle or have enough statistical power to compare between groups, that's great. But if we can't, let's not do what has historically been done, which is just exclude women. So that's kind of the bottom line. Now, there's other aspects of this discussion that are much more complex and challenging. And I think we, as a community, we haven't necessarily figured out all the best practices yet. But for example, we know that neither sex nor gender is binary. So sex is, we usually define sex as biological sex as assigned at birth, often associated with, chromosome XX, XY chromosomes, but gender is the social or societal construct and where that person feels that they fit in. Now, certainly we have people who have a different gender from their sex assigned at birth, who are considered transgender. We have people who are considered non-binary and other ways of identifying. Now, I am not at all claiming to be an expert in any of those areas, but one of the things that we touched on in that editorial, and one of the things that I think is really important, is that we need to do a better job of thinking about how we represent our volunteer community. So the people who volunteer to do our studies. And so we thought in that myself and many, many other people have been thinking about how to include, and again, not to necessarily say, okay, here we are studying trans men to see how their blood pressure responses to exercise are, but to say if we're studying some broad question that doesn't have to do with sex or gender, let's try to include as many people as we can. And if that includes some people who are not traditionally the same gender as the sex they were assigned at birth, then let's be as inclusive as we can within the constraints of our research question.
Yes, that's true. That's something that really has to be thought about more nowadays. Okay, so we started off talking about extreme environments and exercise, et cetera, and then we've talked a lot about biological differences. So why don't we bring those together? So what are some of the biological differences in extreme environments between the sexes? Right.
So thanks, Glenn. Again, this is something that we've been thinking a lot about, especially recently in our group. And for myself personally, it kind of brings together different aspects of my career in a way. So when I was at Mayo, when I was a postdoc, and then when I was on faculty at Mayo, I did a lot of work regarding differences between young men and young women in blood pressure regulation, so autonomic control of blood flow and blood pressure, and then a little bit about how that gets affected at menopause in women. And now in my current work, I'm looking more at environmental, specifically heat exposure, and how men and women may be different or similar in terms of exercise in the heat and their ability to tolerate exercise in the heat. So lately, I've been thinking about how those two things really overlap quite a bit. And I have a slide that I use often in talks recently that's kind of like a Venn diagram showing the sympathetic nervous system controls blood flow, right? Controls blood flow. And actually thermoregulation is an autonomic response, if you think about it. So our autonomic response in terms of sympathetic regulation of blood flow has kind of a Venn diagram that overlaps like this, where blood flow regulation affects blood pressure. So certainly when you have systemic vasodilation, you have a lower blood pressure. And it also affects body temperature, because if you have systemic, especially peripheral vasodilation, you have that's what helps you lower body temperature, especially if you're exercising in the heat. So, but the thing is, those two things don't happen independently of each other, right? So one of the things that we showed when I was still at Mayo was that women tend to have, in general, again, there's a lot of inter-individual variability, but in general, young, healthy women tend to have lower blood pressure and more vasodilation for certain stimuli compared to men. So, for example, if you gave sympathetic stimulation, or if you actually gave norepinephrine, which we did, gave norepinephrine in a brachial artery catheter and measured vasoconstriction in young men and young women, you'll see that young men will have a dose-dependent vasoconstriction, and young women in control conditions will have almost no vasoconstriction. And what we did was we gave a beta blocker to say, is that vasoconstrictor response
just
being
make sure people are clear? Sorry, just because it's a bit of a broader audience.
Sorry about that.
Just make sure we're clear on vasodilation, I just had an asthma one before you.
Oh, right.
Vasodilation.
Sorry. Right. Let me back up.
Beta block. Yeah,
Absolutely. So sorry about that. So women in general, some of the studies that we did and others have done have shown that women in general, if you think of a blood vessel dilating or constricting, if that blood vessel dilates, you'll have more blood flow to a certain area, and maybe your blood pressure will go down depending on what the situation is. Yep. And if that blood vessel constricts, you'll have less blood flow to a given area, and blood pressure might go up. Now, the other thing that happens in the skin circulation is that if you need to have that vasodilation, that blood vessel opening, in order for heat to get dissipated to the environment. So estradiol,
so
as a hormone,
you need to have the blood sent to the skin, basically.
Correct.
Or you can't.
Right.
Exactly.
Right. Now, estrogen or estradiol seems to promote that vasodilator response, and therefore might represent an advantage in women when talking about dissipating body heat.
Exercising the heat.
Right. So, and estradiol tends to promote vasodilation in general, which probably is what helps women have lower blood pressures overall, whether they're in the heat or not. Now, the interesting thing about that, in terms of the overlap between blood pressure regulation and body temperature regulation, is that if you have a hormone, which is estradiol that women have, that tends to promote vasodilation, and this is where I was saying you have to be careful about saying advantages or disadvantages, because it's very specific to the circumstance. So let's say that you had a circumstance where you needed more skin blood flow, you needed more blood flow to go to the surface of your skin, and it was really hot out, and you had to do something outside for a long period of time. Well, you might say, oh, okay, well, women might have an advantage because they're bringing more blood flow to the surface of their skin. Also, women are smaller, which in a lot of environments, on average, are smaller, which in a lot of environments is an advantage because you have a larger surface area to mass ratio, which I won't go into right now, but just being smaller tends to allow you to dissipate heat better in many circumstances. So that's good, right? So you say, okay, well, women are, in that sense, doing a good job of dissipating heat. Well, but also we need to maintain our blood pressure, because what if you're a woman, again, a lot of inter-individual variability, but what if you're a woman that has low blood pressure to begin with, and then you go outside and it's hot and you're doing stuff and you have to stand up, but your blood pressure gets so low that you start to feel dizzy or actually faint. And it turns out that symptom, or that ability to stand up and not pass out, is called orthostatic tolerance. And there's a thing called orthostatic intolerance, which is when you stand up and you feel dizzy or you pass out. And it turns out that women are at greater risk of orthostatic intolerance. So women are more likely to feel dizzy or lightheaded in the heat standing up compared to men. So that's one of the things that's, in my opinion, both an advantage and a disadvantage, because, certainly you might be maintaining a lower blood pressure, which is very good for your cardiovascular health. But if your blood pressure goes too low and you're out in the heat and you're trying to sweat and maybe you're getting dehydrated, which makes your blood pressure go even lower, there's kind of a mixed bag there. Now, what I always like to say, though, is I think that men and women are similar is not that their responses are exactly the same, but as long as the person, whoever's in charge, the coach or the sports leader or the unit leader or whatever, is doing the right precautions. So making sure people stay hydrated, making sure people have adequate rest breaks, making sure people are dressed appropriately, either have enough lighter clothing or have enough heavier clothing if it's cold, which we haven't had time to talk about today. But, as long as we take those appropriate precautions, then no one, men or women or, any group or subgroup in the population will really be at risk, because we know, in general, we know what to do. And as long as we take those same basic precautions, everyone should be doing just fine in the heat or cold.
That's true. I wonder if I can ask you, I know we don't talk too much about cold, but the thing that confuses me, I know that females tend to get, lower blood pressures, as you said, because, the library or something, and they're getting a book and they go to stand up. Oh, it happens much more.
It's a little more common. Yeah, it is a little more common in women. Yeah.
But also, okay. And then you say they can, it's good to be smaller, because, as you said, when you have a smaller, so if you think of a baby, for example, they've got this, they're small, but they've got a huge area to lose heat or gain heat. So is that the same reason that women tend to feel colder as well? Like not even during exercise, but they tend to feel colder? Because I've always been confused by that, because they've got more body fat on average. but they tend to feel colder. Do you know? It's not really exercise.
So great question. First part of the answer to that is that there's a difference between sensation of temperature and actual temperature. So the fact that you feel cold does not mean that you are cold. And an example of that I always give people is that if you have a fever, like let's say you're just getting sick and you're getting a fever, your body temperature is going up, but you're shivering. You feel really cold. And so there's definitely a distinction between sensation of temperature and actual temperature.
Yep.
So that's one thing. The other thing is, so two other thoughts about that. One is that I haven't done a lot of work on sensation of temperature in women, but some people have, and it does change with menstrual cycle status. And there's some things that affect sensation of temperature. But so I'm not sure if surface area to mass is the reason behind sensation being different between men and women. Certainly women have more subcutaneous adiposity, which tends to be an insulator. So
I guess less lean body mass though.
Lower lean body mass, higher fat mass, which would tend to, and by the way, the surface area to mass thing is not as simple as it sounds. So, there's other aspects of, like you said, body composition and specifics of the environment that affect whether or not you gain or lose heat to the environment. But in general, people who are smaller, which isn't always women, but is sometimes women, would tend to be at a disadvantage in the cold, especially if they have like long, lean limbs, for example. That's going to have again a huge surface area to mass ratio, and tend to lose heat to the environment. And so in the cold, those things would be a disadvantage.
What did you say? In terms of heat, you definitely find the Ethiopian and Kenyan distant runners and things tend to be small, and often we'd get upset about how we often had the world record holders and the best runners and things in Australia, but they never won the Olympics because it'd be hot. Right. Big people. Great. All right. Now I've got some questions on Twitter here, and one was because you were talking about estrogen. Kay Lee would love to hear about the relationship between progesterone and higher core temperature. Is a correlation? Is that even a thing? I don't know. Do you know?
It is. I think, and it actually is one of the things that I studied again very early on in my career when I was a PhD student. So yes, so progesterone is considered to be thermogenic. I would say that not all of the mechanisms for that are understood, but that if you look at the mid-luteal phase of the menstrual cycle, so that's the second half of the month of the menstrual cycle where progesterone is the highest, that is the point at which body core temperature tends to be the highest over the course of the month for regularly cycling women. So there is a correlation. It's from the studies that I've done and many others have done, it seems to be a shift, kind of a direct shift to higher core temperatures, meaning that you don't feel it. The person doesn't feel it. It's about half a degree Celsius or about a degree Fahrenheit. And the person may or may not feel it, but they'll just be regulating around that higher temperature. So instead of regulating body temperature to try to get back to that lower temperature that they were at earlier in the month, they'll just basically regulate around the higher temperature. And it's not a huge change, but it is something that's measurable, and I have in fact measured it. So I've seen it, but I would say we don't know all the mechanisms for where that comes from.
Okay, and that's basal. Does that get obliterated during exercise? I guess when you exercise, do you sort of go up to the same temperature or?
Great question. The answer is it depends. I think both things have been shown where there are examples where you maintain it like a DC offset at a higher temperature, or there are other examples where, so for example, the estrogen influence to vasodilate more offsets that initial core temperature difference. So you end up with the same temperature, like during steady state exercise, for example. But it depends on the exercise, it depends on the length of exercise, it depends on the environment. So again, I would be hesitant to make too many broad generalizations about that, but it is an effect that exists.
Okay, so Angela asked, what age groups are we talking about? So I guess just like we talk about, you tend to think about young white males. I guess then we start talking about young white males and young white females. So what about with age? Are there differences in how people can tolerate these extreme
So yes, definitely. I would say Larry Kenny's group at Penn State is probably the group that's done the most work on this area, but others have as well. But where so all of thermoregulatory responses become less robust with aging. In particular, at menopause, there's a big shift in how women regulate blood flow and body temperature. So certainly, if we think about classical or passive heat stroke, meaning not exertional heat stroke that I was talking about earlier, but the type of passive heat stroke that occurs in people in their homes during heat waves, that occurs more in older people because their thermoregulatory mechanisms are not as robust. So definitely when I'm talking about some of these sex difference things and things we've been discussing earlier in the hour, I'm mostly talking, most of the work I've done has been in young, healthy people. And so, certainly we try to do our best to have it not be entirely young white people. I think we're doing a little bit better in that regard recently, but yeah, so almost everything I've been talking about has to do with younger people as opposed to.
Can I ask, with aging, the loss, some of that loss of thermoregulatory ability, is part of that, because often when we're talking about mitochondrial function or just all sorts of things on the podcast, I say, well, how much is the inactivity and how much is the age? Is it the same thing because you're not actually, you're not as likely to be sort of stimulating your thermoregulatory system? I think it was Mike Tipton I had Mike Tipton on, we were talking about cold mainly, and he was talking about, this fact that we're always within 1 degree and, we've got the aircon perfect and we're not really stimulating our thermoregulatory system.
I see what you mean. Yeah.
Is it partly with age because you're not actually stimulating your thermoregulatory system? Maybe you're not exercising as much. You're sort of sitting around, I'm being a bit, with a cup of tea. I was going to say. But anyway, you're probably not as out and about and things. Do we know?
So good question. I think it's related to that to some extent. And the way I think about it is it's similar to exercise or VO2 max. So certainly our VO2 max goes down with age, and that's going to happen whether we're extremely active or not, right? So, but you can fix it a little bit. You can shift up to that higher VO2 max if you're training or if you start training. So I think the same is true for thermoregulatory variables, that you can definitely train more in the heat, whatever age you're at, and you can be better adapted to the heat. But overall, that slope is still going to be negative.
Okay, we're sort of out of time, and I felt a bit awkward earlier on with some of the stuff, but it sounds like I maybe did all right. How about we finish up with some takeaway messages from our chat?
Great, thank you so much, Glenn. So takeaway messages. First of all, thank you for having me on the show. I think it's just delightful. As I said, I'm very honored to be here with you. And thanks for the really honest conversation about, things related to sex as a biological variable. I think you maybe can help a lot of people to think about this who had, have not necessarily thought through some of the aspects. So for take home messages, I would say, first of all, in general, with heat, some of the things we talked about earlier, with heat exposure, exercise, certainly hydration is important, but it's not the only thing. Definitely try to stay hydrated, but pay attention to, how you're doing, how you're feeling, et cetera, even if you are hydrated. Second, we talked about electrolytes. I think it's just fine to have carbohydrate electrolyte beverages. I don't think you absolutely need them. So if you don't like them, definitely don't force yourself to drink them. But as long as you're eating normal food and having regular, basically planning well, you don't need those high electrolyte drinks such as oral rehydration solutions. So let's see, and then we talked about sex as a biological variable. Again, my take home messages from that are, please just do your best. Everyone out there who's doing research in any field, not just exercise or thermoregulation, but any field, please just do your best to include men and women and just in general be as inclusive as you can. If you can, then it is a best practice. If you're studying sex differences, then you should power for both, have enough statistical power for that. You should control for the menstrual cycle, again, if you can. But please, please, please do not exclude women if you don't have the capacity to do those things. Just do your best. If you can include 2 women in a group of 10, great. Just include them and do your best to include that sex is a biological variable, as I said, just like any other variable. just to be inclusive. And then finally, again, the things that we've been talking about today, that I talked about today, are primarily based on the work that I've done, which has mostly been in young, healthy people. So I would say between the ages of, let's say, 18 and 40 or so. So there are definitely differences and changes that occur in thermoregulatory responses and blood pressure responses with aging that we really haven't touched on today. So thank you, Glenn.
Right. Now, if people are feeling a bit nervous, they've got an N equals, I don't know, 12 or something men and 3 females and a woman. And they're like, oh, can that might be good for your citations of that. So tell us quickly.
Absolutely.
Because I was saying,
yes.
well, based on this
Usselman et al. 2023.
Sorry,
it is. It's a. I believe it's published as an editorial, but it just came out. So if you look up Usselman, Ussleman et al. You can take a look at that and or email me, get in touch with me. I'll tell you exactly how to handle any reviewers that might give you an issue with that.
Perfect. All right. Well, that helps your citations and helps them to get published as well. So it's win-win. Okay. Well, thank you very much again for coming on. See you.
Thanks so much, Glenn.
Okay. Bye-bye.
Bye.
I hope you enjoyed this podcast, and please like, subscribe, pass it on to your friends and colleagues. Check out the other podcasts. Thanks again.